This is the Masking Handbook for Audiometry. This video is on bone conduction, interaural attenuation. We found 4 studies that looked at interaural attenuation for bone conduction. The 4 studies used our radio ear bone conduction device, which is a typical clinical device, and they included a mastoid location for the testing. The studies included those who had at least a severe hearing loss in one ear and quite good hearing in the opposite ear. The total subject pool was 158. One thing we should recognize is that many or most of us have been taught that attenuation for bone conduction is 0 dB. Research on attenuation includes subjects who have pretty good hearing in one ear and at least a severe to profound hearing loss in the other ear. Unmasked testing is completed on both sides, and the IA value would be the difference in threshold responses from the two sides. If 0 dB is a true interaural attenuation value, then findings from a bone conduction IA study would look like this. The unmasked bone line from the non-hearing side would perfectly match the unmasked bone line from the hearing side. Here is a summary spreadsheet of the bone conduction interaural attenuation findings. Look at the mean, medians, values. Definite attenuation from one side to the other on average. Another interesting point is that for the minimum possible attenuation, negative attenuation was definitely measured. This summary graphic shows a compilation of the data. Wide variability in bone conduction attenuation is clearly possible. Let's look at 500 Hertz. The mean or average attenuation at 500 Hertz is 7.6 dB. The maximum attenuation found was 35 dB. So that's from the mastoid location of the non-hearing ear compared to the good hearing side. A difference of 35 dB was measured. That's quite a lot of attenuation. The minimum value at 500 Hertz was minus 16 dB. What that's referring to is that when the bone conductor was placed on the non-hearing side, at least one subject heard it 16 dB better than when it was placed on the better hearing side. So that's an example of negative attenuation. If 0 dB bone conduction interaural attenuation was actually the case, our unmasked bone conduction responses when the device is placed on each side would look like this. The bone conduction responses would be equal between right and left sides. That would be 0 dB attenuation. On average, however, this isn't the case. It's more likely that unmasked bone conduction responses would look like this, where the head provides a certain amount of attenuation from the non-hearing to the hearing side. The information shows also that this is possible, where subjects hear bone conduction signals better when the device is placed on the non-hearing side compared to when it's placed on the hearing side. This is the negative attenuation situation. So if we adopt min IA values, or minimum possible interaural attenuation values, for all the various devices, if we take numbers directly from the various studies, they'll look like this. As you can see, minimum possible attenuation for bone conduction is not 0 dB. Whether we should actually use these min IA values for bone conduction is a whole other topic of discussion. Why might there be negative interaural attenuation for bone conduction? In 2012, Stefan Stenfeldt suggested the following options. Of course, variability due to placement and positioning may affect results. In other words, if you get a good fit of the bone conductor on one side and a poor contact position on the other side, that could affect bone conduction results. But he also suggested other possibilities. He also noted that bone conduction hearing is a complex situation. He stated, several pathways contribute to the sound pressure in the cochlea during bone conduction stimulation, and they may add constructively and destructively according to their relative phase. So since we're dealing with tonal signals, there may be phase canceling or phase enhancement effects. When using a bone conductor, the device delivers pure tone signals into the bone tissues of the head. The signal emanating through the bone tissues may diverge, creating several pathways to either cochlea. This could lead to phase enhancement effects or phase cancellation effects. 0 dB for bone conduction is a theoretical value. It streamlines the situation into a digestible and workable idea. This allows for efficient thinking and practice during audiometry. It's also a time saver. It is going to be the recommended interaural attenuation value. However, we should acknowledge that in many situations it may not reflect reality. In order to find a true best cochlear response when completing unmasked bone conduction testing, it's likely that the device should be placed on each side and unmasked testing be completed. This is the Masking Handbook for Audiometry. If you liked this video, you'll love the handbook. For more resources on masking and to learn how to purchase the book, check out maskinghandbook.com.